Cześć, party. All right, in this video we're going to be talking about alternating series, which is getting close to one of our last tests, one of our last series types. We've kind of talked about alternating sequences before, where essentially I have something that's multiplied by -1 to the n, or to the n plus 1, or later on could be like cosine of pi n. But essentially, alternating just means that I have like +1, -1/2, +1 fourth, -1 eighth, so on and so forth, right? This is actually a geometric series right there, but essentially the point that I'm trying to get across is they will alternate the signs in some way, somehow. They go back and forth, right? So that's essentially what this beginning is saying. Given an alternating series like this or like this, notice they both go to infinity, the series converges if the limit of the non-alternating part, so notice that is of the a sub n, right? If that goes to 0, as well as my terms are getting smaller, essentially is what that is saying, that my nth term is bigger than my n plus 1th term. So if the terms continuously get smaller. All right. So let's take a look into this first one. So I'm going to call a sub n, again, it's the non-alternating part, so it's just 1 over e to the n. So then what I'm going to check first, and what I usually check first, is that a sub n is greater than or equal to a sub n plus 1. So it's just going to be a matter of plugging stuff in. Cool. So 1 over e to the n is greater than or equal to 1 over e to the n plus 1. Again, just like we were doing in one of those other videos, I can't remember, I think it was direct comparison. But if I'm going from 1 to infinity, then I'm going to be staying positive. So what that means is normally we can't multiply across the inequality because we don't know how it's going to affect it. But since the n is positive here, n is positive here, I can multiply by positive numbers and I'm not going to have to change my inequality. So e to the n plus 1 is indeed larger than or equal to e to the n forever and ever. So what that means is my first statement is correct. I am greater than my next terms. Now I really just need to check if the non-alternating part goes to 0. So if I take the limit of this, it will indeed go to 0, right? Because that's 1 over e to the infinity. So I'm just going to get into my statement. So since a sub n is greater than or equal to a sub n plus 1, and notice I do make the statement that a sub n is equal to 1 over e to the n. That is important if you're going to just say the a sub n and a sub n plus 1. Otherwise, I would have to make this statement as my right here. So it's whatever you want to do. I prefer to define what a sub n is, though. And the limit as n approaches infinity of a sub n equals 0. The series converges by the alternating series test. Or the series is a convergent alternating series. Either way you want to say that. Doesn't really make a difference. All right, next. So again, take out the alternating part. That is this. That is the alternating part on this one. So I'm going to say that a sub n is n over 3n plus 2. Just looking at the nth term, I'm not even going to worry about doing the a sub n as greater than or equal to a sub n plus 1. You can, but since the limit as n approaches infinity of a sub n equals 1/3, which does not equal 0, the series diverges by alternating series test. Done. Kind of like E and the S together there. I don't know. TST. I don't know. All right. So this one, you wouldn't normally think of as an alternating series, but you have to remember that if you're plugging in integers, then that is our alternating part, right? So we have cosine of 1 pi, which is 1. Cosine of 2 pi, which is -1. Cosine of 3 pi, which is back to 1. So it's going +1, -1, +1, -1, and it is over n. So my a sub n is 1 over n. I think this is going to converge, so let's make sure that it gets smaller. So a sub n needs to be greater than or equal to a sub n plus 1. So 1 over n needs to be greater than or equal to 1 over n plus 1. That is going to be true. And I can verify by cross multiplication that n plus 1 is definitely greater than just n. So I'm going to say since a sub n greater than or equal to a sub n plus 1, and the limit as n approaches infinity of a sub n equals 0, the series converges by the alternating series test. So maybe you have the question like, well, if it was 1 over n, that's a divergent p-series. And I would agree with you, right? That's going to be true. So this will converge for alternating series, but this also brings up the question of, does it always converge, or does it just converge in this situation, or what? So what mathematicians did is they brought up something called absolute and conditional convergence, which you are not going to have to state unless we ask you, does the sequence converge absolutely, conditionally, or does it diverge? So if it, my wife is vacuuming. Okay, cool. If it absolutely converges, then the absolute value converges as well as the series converges itself. It conditionally converges if the absolute diverges, but the series converges itself. So all that is, right, is if we think about this last one would be considered a conditional convergence. Because if I take the absolute value, right, that gets rid of the alternating part. So this is really coming up when we're talking about alternating series kind of exclusively, but we could ask it any time really. But if I take the absolute value, that would be a divergent series. So this one would be technically said to converge conditionally, but truly we are not going to be asking for that, or you're not going to have to state that unless we are specifically asking if it converges absolutely, conditionally, or it diverges. We will specifically say these two words if that is what we are looking for. AP test is going to be the same way. So let's see, if I'm absolutely or conditionally, I have the absolute value of the series diverges, right? And if it's divergent, then I would just check the a sub n, because that converges in both of them. So if I show it diverges in the a sub n, then it diverges altogether. So looking at this first one, just off the bat, I'm thinking it is going to diverge, or sorry, it's going to converge conditionally, because I do have an alternating part. This is going to be kind of tedious, but let's take a sub n as 1 over n plus 3. Then I'm going to say a sub n is greater than or equal to a sub n plus 1. So 1 over n plus 3 greater than or equal to 1 over n plus 4. N plus 4 is definitely greater than or equal to n plus 3. So I'm going to say since the series for a sub n converges with the limit as n approaches infinity of a sub n equaling 0, and a sub n is greater than or equal to a sub n plus 1, and the absolute value one is the next one I need to check, right? So if this is divergent, which I think it is going to be, has to be, right? Because if I were to just take the absolute value of this, right here, let me write this off to the side. I usually don't need to see this because we can just think about it. Equals 1 to infinity. If the absolute value, if I take the absolute value of this thing, that gets rid of my alternating part. So that would be n plus 3. This is a divergent. I can compare it to a p-series. So I'm going to compare it to b sub n, which is 1 over n. And let's see, b sub n is, Let's do the limit comparison. A sub n over b sub n. Right, it was just 1. So I know b is sub n. So I know this is divergent. With limit as n approaches infinity of a sub n over b sub n equals 1, which means it's finite and positive. Divergent with the, what is this called, limit comparison? Because b sub n, the series for b sub n, is a divergent p series. With p equaling 1. Okay, so that means the series of -1 n plus 1 a sub n is conditionally convergent. Right, so this is super duper uber annoying because you are going to have to state everything. So really here's where it's important to pick a nice test. See, we could have done, no, because that's bigger. Yeah, I couldn't have done direct comparison. That would need to be, can't think straight. Yeah, it's smaller. I couldn't have done direct comparison. But you're going to need to be super tedious about stating everything that you know and why you know it. It's going to be annoying, but we need to see all of it. I'm so sorry. I'm so sorry. All right. So when we have divergent ones, those are super nice. This one, let's see, a sub n equals 1 over e to the n squared. And we can compare it to b sub n, which is 1 over e to the n, because that is bigger and that's going to converge by a geometric series. But I do need to state the alternating part. It's greater than or equal to a sub n plus 1. So 1 over e to the n squared is greater than or equal to 1 over e to the n plus 1 squared, which is a true statement. Right, that is good. Okay, and then since a sub n is greater than or equal to a sub n plus 1, and the limit as n approaches infinity of a sub n equals 0, the regular series my alternating part converges. And how do we know? By the alternating series. Also, the absolute value of it converges by direct comparison because, let's see, a sub n, I want this to be less than b sub n. So 1 over e to the n squared is less than 1 over e to the n, which means e to the n is less than e to the n squared, which has got to be true. So a sub n is less than b sub n, and the series for b sub n is a convergent geometric series with r equals 1 over e, which is less than 1. Cool. So you got to state everything. It's the most tedious part. You may have maybe one of these on the free response for your BC BP test. Maybe. All right, moving on. This one's going to diverge. So I'm just going to take a sub n, 2n plus 3 over n plus 10. Since the limit as n approaches infinity of a sub n equals 2, which is not equal to 0, the series diverges by the nth term test. So you really hope these things are going to diverge. But yeah, it's just going to be stating every single part. So how you know that your original converges, how you know that this one converges, you need everything. So just take your time with your statement. Because again, like I said in the last video too, in 9.4, the statement is where you guys are going to miss the points. So you need every single little thing, what test you used, how you know that test works, and how that relates all back to your original series that they're asking about. All right, but that's it for this one. Hopefully this was helpful, and I will see y'all soon. Bye-bye.